In this video, we will learn about the Mediator design pattern and how to implement it using C++ code. Mediator is a behavioral design pattern that allows us to reduce objects' dependencies on each other. We use it to force all of the objects to communicate through a mediator object, instead of being able to communicate directly with one another. Let's look at how we can implement the Mediator design pattern using C++ code. First, we will declare a class named baseComponent. Next, we will create a class named Mediator, inside of which is a public virtual void function named Notify that takes in two parameters, a pointer to a base component named Sender, and a string named Event that we mark as purely virtual by typing const equals 0. After that, we will create a class named baseComponent. We will create a protected pointer to a mediator named Mediator. Then we will use the public access modifier. Let's add a constructor to our baseComponent class that takes in a pointer to a mediator named M, initialized to a null pointer by default. Next, we will have a function with a void return type named setMediator that takes in a pointer to a mediator named M. Inside of this function, we will set mediator equal to M. Then we will create a class named Component1 that extends the baseComponent class with public accessibility. Inside of this class, we will use the public access modifier. Next, we will have a function with a void return type named performOperation1, inside of which we will output the string Component1 performs operation 1, and then a new line to the console. Then we will call the mediator's notify function and pass in this as the first argument, and the string operation1 as the second argument. Next, we will create a function with a void return type named performOperation2, inside of which we will output the string Component1 performs operation 2 to the console, followed by a new line. Then we will call the mediator's notify function and pass in this as the first argument, and the string operation2 as the second argument. Then we will create a class named Component2 that extends the baseComponent class with public accessibility. Inside of this function, we will have a function with a void return type named performOperation3, inside of which we will output the string Component2 performs operation 3 to the console, and then a new line. After that, we will call the mediator's notify function, and pass in this as the first argument, and the string operation3 as the second argument. Next, we will have a function with a void return type named performOperation4, inside of which we will output Component2 performs operation 4 to the console, and then a new line. After that, we will call the mediator's notify function and pass in this as the first argument, and the string operation4 as the second argument. Then we will create a class named concreteMediator that extends the mediator class with public accessibility. Inside of this function, we will have a pointer to a Component1 object named Component1, and a pointer to a Component2 object named Component2. Next up, we will have the public access modifier, and create a constructor for our concreteMediator class. The constructor will take in two parameters, a pointer to a Component1 named C1, and a pointer to a Component2 named C2, which will set the value of Component1 to C1 and Component2 to C2 respectively. Then we will call Component1's setMediator function and pass in this, and then Component2's setMediator function and pass in this. Next, we will override the base class's notify function. Inside of here, we will check if event is equal to the string operation1. If so, we will output mediator reacts on operation 1 and triggers the following operations, and then a new line to the console. After that, we will call Component2's performOperation3 function. If event is equal to the string operation4, we will output the string mediator reacts on operation 4, and triggers the following operations, and then a new line to the console. Then we will call Component1's performOperation2 function, and then Component2's performOperation3 function. Time to test our code. Let's go inside of C++'s main function. Inside of here, we will create a pointer to a Component1 object named C1 that we set equal to a new Component1 object. Then we will create a pointer to a Component2 object named C2 that we set equal to a new Component2 object. Next, we will create a pointer to a concreteMediator named Mediator that we set to a new concreteMediator object with C1 passed in as the first argument, and C2 passed in as the second argument. Then we will output the string client triggers operation 1, and then a new line to the console. After that, we will call C1's performOperation1 function. Next, we will output a new line to the console. Then we will output the string client triggers operation 4, and then a new line to the console. After that, we will call C2's perform operation 4 function. On line 6, we can remove the opening and closing curly brace, since we just want to declare the function at this point in the program, and not define it. When we run the code, notice that we successfully implemented the Mediator design pattern based on the program output. Nice job. We should use the Mediator design pattern when it is hard to change some of the classes in our program, because they are tightly coupled to some of the other classes. When we can't reuse a component in a different program because it is too dependent on other program components, and when we find ourselves creating a bunch of subclasses of a component just to reuse some basic behavior in different scenarios. The advantages of using the Mediator design pattern are that it follows the single responsibility principle. We can introduce new mediators without having to change the components themselves. We can reduce the coupling between the objects in our program. And we can reuse the functionality of components more easily. The disadvantage of using the Mediator pattern is that if we are not careful, over time our Mediator can grow into a large monolithic class.